All right, folks, in today's class, we're going to be talking about polynomials, and specifically, we're going to be talking about collecting like terms. A polynomial is something with many terms, many nomials terms. What's a term? A term is a part of an equation that's separated by a addition sign, a minus sign, or an equal sign. So if we look at this equation, we see that there are quite a few terms. Our output, f of x, is a term. X squared is a term. You see the equal sign, the addition, 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 and addition. So everything that's separated by addition and this equal sign, these are all separate terms. So a term, x squared is a term, 2x is a term, 4, 3x, 1, and 2x squared are all terms. Now what we're going to be doing today is we're going to be simplifying this equation by collecting like terms. And let me remind you, we're going to use Algebra Tiles to help us understand what we're doing. So remember that a small square equals 1, and a shaded square equals -1. A rectangle is x, and a shaded rectangle is -x. A large square is x squared, and a shaded large square is -x squared. So all we're going to do is we're going to use Algebra Tiles to represent our equation. So there's an x squared, so I'm going to use an x squared, and I'm going to run out of room, so I'm going to have to do this imaginatively. So here we have 1x, here we have 2 x's, 1, 2, 3, and 4. And when I'm using Algebra Tiles, anything that's red is a negative. It corresponds to shaded. So that's 1, 2, and 3. Let me add in, now that's that 1 that's right there, 1. And then 2x squared. I'll do this down here at the bottom. 2x squared. So x squared, x squared. 2 x's, 2 x's. 4, 1, 2, 3, 4. 3x, 1, 2, 3. Positive 1, positive 1. 2x squared, 1, 2. Now, what I'm going to do to collect like terms is we're just going to count up everything that's the same. So all of my x squareds, all of my x's, and all of my 1s, we're going to count up and see what we have. And we're going to go from there. 1, 2, 3. So let me actually move this down, and I'll put everything right down here. So that's 3x squared. And let me write in my f of x, because this is an equation. So 3x squared, those are done. I'm going to move those out of the way so I don't recount them accidentally. 1, 2, 3, 4, 5. These are all positive, so it would be positive 5x. Move all of these out of the way. 1, 2, 3, 4, 5. Positive 5. So that's 3x squared plus 5x plus 5. Now the last thing I want us to do as we're doing our work today in collecting like terms is we need to be able to identify what's going on here. So here we have, this is called, what we end up with is standard form of a quadratic function. It's quadratic because one of our x's is squared. This is a quadratic function. If we graph this, we would get a parabola. So what we need to understand is the terms. Each one of these terms has a name, and then each one of these coefficients also has a name. So we had x squared, so this is a term that's separated by a equal sign and a positive sign. So this is the quadratic term. So the quadratic term is the one that has the x squared. This is the quadratic term. So I'm simply going to write 3x squared. Excuse me. Now, the linear term would be very, very similar to our m times x in our slope-intercept form, y equals mx plus b. M times x would be the linear part of that equation, and this is the linear part of the quadratic equation. So this would be 5x. So if I could just cover this up, that looks like slope-intercept form, mx plus b. So this part, 5x, is our linear term, and then 5 is our constant. Now, we also need to know the coefficients. How many x squareds did I have? How many of these x squareds were in this equation? I have 3. So I'm going to write 3. This is the quadratic coefficient. It's the number of x squares. And then how many x's did we have? How many x's did we end up having? We had 5. And then the constant is a little bit tricky because it's both a term and a coefficient. So the constant is 5 because there were 5 ones. Now let me do one last thing before I let you go. If I have this on my board, or on my desk, or on my notebook, or in a problem, negative x plus x plus x. So what I have here is negative x plus 2x. Sorry, that's not an x, that's a 2. Negative x plus 2x. Well, what does this equal? If I collect like terms, if I simplify this, what's a negative and a positive make? When I add them together, a negative and a positive. What's 1 minus 1? 0. What's 8 minus 8? 0. What's negative 12 plus 12? 0. So when my signs are opposite and I combine like terms, when I add them together, negative x plus x makes 0. So this will equal simply 1x. And this right here, just in case you've forgotten when you've done algebra tiles in the past, anytime that I add two pieces together that are opposite signs, this equals a 0 pair. 1x minus x is 0. And that works with ones, and that works with x squareds as well. X squared minus x squared is 0. 1 minus 1 is 0. X minus x is 0.